this is our last video for Unit 7, which is our two-step equations video. So make sure that you're ready to take notes as we move through the slides. So let's think about our ultimate goal in solving an equation. How can knowing how to solve a one-step equation help you know how to solve a two-step equation? So we already know how to do x minus 4 equals 6. We know how to do 2x equals 12. So we want to know how can we do 3x minus 5 equals 13. The same goal is that we need to figure out what value can we put in for x to make that equation true. So the steps for solving two steps, so this should say two steps. So if you have the notes packet, or if you already wrote that down, make sure you change that to two step. And then I would like you, they're similar to one step, but I would like you to pause and write this down. You can write it in your own terms, but just like one step, we rewrite the equation, draw the train tracks, isolate the variable, but this time we have two steps. We use the inverse operation to remove the constant from the variable, so we add or subtract, and then we remove the coefficient from the variable, and we multiply or divide. Then we solve, then we check. So let's do some two-step equations. Write all of these down in your notebook and do them with me. So 2x plus 3 equals 9. Here's our first equation. First, we do our train tracks. Then we look at the side with the variable and we see that it is on the left side. So we need to do two different things to get x alone. I always say that we first get rid of the number that is the least attached. So like the 2 is attached to the x. So we're going to get rid of the 3 first. It's the least attached. So because we're adding 3 to the x, we're going to undo it, and we're going to do the opposite, which now we know is subtracting 3. And we're going to do that on both sides, because remember, whatever we do to one side, we have to do to the other. So then I'm going to draw my line. And I know that 3 minus 3 is 0, so that leaves me with 2x. So I bring down what I have left, which is my 2x, and then I do 9 minus 3 equals 6. Now I have 2x equals 6, which looks like an equation that we've done before because it's a multiplication one step. X is being multiplied by 2, so I'm going to do the opposite, and I'm going to divide both sides by 2. 2 divided by 2 is 1. It gives me x, and 6 divided by 2 is 3. This is when it's super duper important to go back and check, because this is sometimes when we make mistakes on the steps. So we want to check, and what I'm going to do is I'm going to go back to my equation and I'm going to put 3 in for x. 2 times 3 plus 3 equals 9. 2 times 3 is 6 plus 3 is 9, so that checks. So my answer would be x equals 3. Let's do another one. 2x plus 4 equals 10. Write this in your notebook. Do your train tracks. The adding 4 is the least attached, so usually we're going to add or subtract first, and then we're going to multiply or divide second. So the opposite of adding 4 is subtracting 4. I'm going to do that on both sides. So we're left with 2x equals 6, which is exactly the same what we had before. We're going to divide both sides by 2. X equals 3. Let's put that in. 2 times 3 plus 4 equals 10. And does it equal 10? 6 plus 4 equals 10. So yes, that works. 3x plus 1 equals 7. Let's write this down. Do my tracks. 3x and then, or x is being multiplied by 3 and then added to 1, and we get 7. So it's kind of like we're doing the opposite of PEMDAS. Adding comes last, or adding comes after multiplying, so we're going to do that first, and we're going to undo it. So the opposite of adding is subtracting, so subtract 1 on both sides. We have 3x equals 6, because that's 0. Divide both sides by 3. X equals 2. Let's put that in. 3 times 2 plus 1 equals 7. 3 times 2 is 6 plus 1 equals 7. So x does equal 2. Okay, last one on this slide. M divided by 3 minus 5 equals 2. So something divided by 3 and then subtracting 5 equals 2. So we're going to add 5 to both sides because the subtraction happened last. So we're going to undo it and have that be first. We bring my m divided by 3. That cancels. 2 plus 5 is 7. So then, remember, if we have a variable and it's being divided by something, we do the opposite and we multiply. So really, it's 3 over 1. 3 times m divided by 3 is just going to cancel it out to m equals 21. So let's try that. 21 divided by 3 is 7, minus 5 is 2. So m equals 21. Pause the video and try these two on your own and then come back and check your work. Okay, so I have 3x plus 2 equals 23. I subtracted 2 from both sides, so I got 3x equals 21. Then we're going to divide both sides by 3, which gets me x equals 7. I checked it, and it worked. So then x does, in fact, equal 7. And then 2y minus 7 equals 3. So because 2y subtracted 7, I'm going to do the opposite and add 7 to both sides. Notice how nice and neat and organized I am. I put the plus 7 right underneath the subtracting 7, and I put it right underneath the 3, so it stays organized. Bring my 2y down. 3 plus 7 is 10, and then 2y equals 10, so I'm going to divide both sides by 2, which gives me y equals 5, and then I checked it. 2 times 5 is 10, minus 7 equals 3. So then y does equal 5. We're just going to do a couple of these on this slide. So I want you to write down 4 plus 5r equals 15. So we're going to do our tracks. This time the 4 plus 5r is, so the 4 plus comes first. But I'm still going to get rid of that because, again, that's the least attached. Plus, if I was following order of operations, I would do 5 times r and then add 4, and I'm undoing it and going backwards direction. So I'm going to subtract 4 on both sides. Notice I still line it up right underneath the 4. Minus 4. 4 minus 4 is 0, so then I have 5r equals 10. And then we know from here, we divide by 5, r equals 2. So then we're going to do 4 plus 5 times 2, which is 4 plus 10, which is 14. So then r equals 2. We're going to skip over to this one. 1/5 x minus 3 equals 17. So write this down, do your tracks. Pause me if you want to try it on your own. Add 3 to both sides, because again, x is being multiplied by 1/5 and then subtracted 3. So we're going to go opposite order and undo it. So we bring down 1/5 x equals 20. And then if you remember what we do when we have a fraction, remember we multiply times the reciprocal on both sides. I'm going to make 20 a fraction just because then it's easy for me. So 5 over 1 times 1/5 is 1. So we just bring x equals 100. And then let's check that. So 1/5 times 100, which is really 1/5 of 100 is 20, because 100 divided by 5 is 20. So, and then minus 3, 20 minus 3 gives me 17. So then x equals 100. Then here's a few more problems that I want you to do. So just disregard the thing that says posting on Class Kick. I would like you to complete these in your notebook. And so pause the video, complete these in your notebook, come back and check your work and make any corrections that you get wrong. It's okay if you get them wrong, as long as you're watching me and understanding your mistakes and then changing it so that you have it correct. All right, so for the first one, 15w minus 45 equals 465. Notice that I added 45, which got me 15w equals 510. Divide both sides by 15, and I get w equals 34, and then I checked it, and that's what I got. 44 equals 12 plus 8b. Notice that my variable is on the right side, which means that I'm looking at the right side, and I'm subtracting 12 on both sides. And I lined it up right underneath where it goes. 12 minus 12 is 0, so then I'm left with 8b equals 32. Divide both sides by 8, and I get b equals 4. And there's my check. And then 4 equals r divided by 5 minus 16. Again, my variable is on the right side. So I add 16 and I get 20. And then r divided by 5 equals 20. And then remember, we multiply both sides by 5 and we get r equals 100. And there's my check. So make sure that you have these safely in your notebook, in your folder, in your backpack, or whatever. And have a good day.